Hey everyone, welcome to another session of CeerazzleDazzlePhysics. In today's session, guys, we're going to be talking about potential dividers, guys. So put down today's title, it's going to be potential dividers. And guys, make sure you hit the like and subscribe button to keep my channel going, guys, and keep my content as free as possible. Right, let's get straight into it. So what exactly is a potential divider? What is a potential divider? Right, so a potential divider is the following. It is a simple electrical circuit that uses resistors, and by resistors I mean including thermistors and LDRs, to obtain a variable potential difference. So it's a simple circuit that uses resistors to obtain a variable potential difference. Okay, so to explain this a bit better, guys, we're going to look at the following circuit. So let's say here's a simple circuit, guys, it's a series circuit. We know this is the voltage coming in on the left-hand side over here. On the right-hand side, this is the voltage of the first resistor. Let's call this one R1. So therefore, this is the voltage V1. Yeah? And let's call this one the second resistor R2. This one will be V2 over here. Happy with this? Right, so the key thing is this, guys. Right, so you know that the voltage V1 is related to the voltage coming in and the voltage across the second resistor over here. We're going to try and connect them by proving the potential divider formula. And it's quite simple, guys. We'll do it very slowly. So hopefully we can have the following expression right now, that we know that the voltage going in will be equal to V1 plus V2. Over here, yes, because this is Kirchoff's first law. The sum of the voltage in is equal to the sum of the voltage out in one complete loop. Now from here, guys, we also know that for resistor R1 right now over here, let's say I wanted to work out V1. I want to work out V1. Well, we know that V1 will also obey Ohm's law, so that'll be equal to the current flowing through it. Don't forget, there's going to be a current flowing through. Here's my current right now. It'll be equal to the current flowing through it times by R1 over here. Very good. Right, now, what exactly is the current flowing through it? What exactly is that current flowing through R1? Well, hopefully we can remember that if we were to draw this circuit again, very briefly on the left-hand side over here, let's just say we were to draw it again, and we were to combine both resistors together, this one over here. Okay, so now we've combined both those resistors together. This one will be equal to R1 plus R2 because resistors in series are combined together to make R1 plus R2. That's the resistance in total. So this will be equal to the resistance in total in the series circuit over here. Okay, right. So don't forget this is still V in on this side over here. This is still V in on this side over here. Right, now, you know that for this circuit over here, we can link them very easily, the current and the voltage. We know due to Ohm's law, voltage is equal to current multiplied by the resistance. Okay, the voltage in will be equal to the current, yes, it's the total current, you don't forget current, times by the resistance in total over here. There we go, the resistance in total over here. So now, guys, we have an expression for the current. Yeah, we can have the expression for the current. So the next line is going to be the voltage going in will be equal to the current times by, open bracket, look, R1 plus R2. There we go. Excellent. Now, everyone, from here, I'm going to substitute this equation that we've got over here into the one over here, on this side over here. So we can do this, guys, we can rearrange this. So current is equal to the voltage going in, total voltage going in, divided by, open bracket, R1 plus R2. Here we go. Let's close that bracket over here. And now look, guys, let's plug that into here. So we're going to now substitute it, guys, into over here, guys. Whoops-a-daisy. We're going to plug it into this one over here, guys. We're going to plug it into here. Over here, guys. So therefore, V1, yes, the voltage across 1 will be equal to V in divided by R1 plus R2. And don't forget, guys, we're multiplying it by R1 at the top over here. And that is our potential divider formula, guys. That is our potential divider formula over here. And sometimes you go, they try and put the R first, guys, to make it a bit easier for us to see. So therefore, the voltage across the first resistor will be equal to R1 over R1 plus R2, close bracket, times by V in over here. Excellent, guys. Really good stuff. So there we go. That is our potential divider formula right now. So obviously, if I wanted to work out V2, guys, it's roughly the same thing. You can do the proof yourself. You will find out that V2 will be equal to, guys, V2 will be equal to R2 divided by R1 plus R2 times by V in over here. So obviously, guys, you can get another permutation of the formula, guys, depending upon which resistor you're looking at, guys, over here. Okay, right, so now we've got the formula, guys, for the potential divider, guys, over here. We're going to look at it in a question, guys. Okay, so what about the following question? Okay, right, so here's the following question. Calculate the voltage around the 200 ohm resistor, guys. And here's a potential divider formula, guys, which we just proved a second ago. First of all, let's label it. So this one is going to be R1, this one's going to be R2. This is therefore going to be voltage 1 across this resistor over here, and voltage 2 across this resistor over here. Right, so we're trying to find out what this one is. Yes, so 200 ohm resistor, guys, so it's R2. So it's R2 we're looking for. So the voltage across the second resistor will be equal to R2 divided by R1 plus R2, close bracket, times by V in over here. Now, from here, we know that V2 will be equal to the value of R2. What is it? 200 ohms, guys, divided by, next one, 100 ohms plus 200 ohms. Don't forget, because that's R1 in this case now, times by the voltage going into my circuit, times by 12 volts over here. So therefore, V2 is equal to 200 ohms divided by 300 ohms, guys, times by 12 volts. So obviously, guys, so the cancellation occurs. So cancel, 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 cancel. 2/3 of 12, guys. The voltage across the second terminal will be equal to 8 volts over here, guys. There we go, guys. So the voltage across there, guys, will be 8 volts. So this voltage is now equal to 8 volts here. And then obviously, due to Kirchoff's first law, if you really wanted to, you can find out the other one. Well, you can just obviously use the formula again, which is the long way around. But you know it's 12 volts coming in, 8 volts dropped off over here. This one will be equal to 4 volts over here. Excellent stuff, guys. And that's it, guys. We'll have a quick recap right from the top. Right, so potential dividers. What is a potential divider? It is a simple electrical circuit that uses resistors, including thermistors and LDRs, to obtain a variable potential difference. And we have a formula which we proved, guys. First of all, this is how I did it. I said I looked at this circuit over here. The voltage in is equal to the voltage out. That's the first bit. And also we looked at Ohm's law for this resistor. The voltage across it will be equal to the current times by the resistance of that resistor. I then combined both these two together to make one resistor, and that will be the resistance in total. Therefore, the voltage going in is equal to the current times by the resistance in total. So that's another bit of Ohm's law we did for this circuit. The voltage going in is equal to the current times by resistor 1 plus resistor 2. Don't forget, because that's our total. I then made current the subject of the formula. Current is equal to voltage in divided by R1 plus R2. I then threw that into here. We ended up with V1 is equal to V in divided by R1 plus R2 times by R1 at the top. And obviously, guys, you can use that expression for V2. So there we go. At the bottom, I've redrawn it out. And for V2, guys, if you wanted to work out V2, it's the same, guys. I've just put R2 instead of R1 over here. But it's divided by the total resistance at the bottom. Excellent stuff. Right, scrolling down, we have the following. So we're going to calculate the voltage across the 200 ohm resistor, guys. V1 is equal to R1 divided by R1 plus R2 times by the voltage going in. And obviously, I identified R1 and R2. Then I just plug the numbers in, guys, and I end up with 8 volts over here. Easy stuff. Okay, guys, and from here, guys, you can actually see on the left-hand side, guys, obviously, if you have 3 resistors in series, guys, you have a long-winded formula now, guys, but it's obviously the same. You can prove that if you want to, yeah? Easy stuff. Okay, and that's it for another session of CeerazzleDazzlePhysics. Make sure you hit the like and subscribe button to keep my channel going, and good luck in your academic studies. Ciao, ciao, and goodbye.